Hello friends, in previous video we have seen how to find out output impedance, transconductance, and now we will see how to find out DC voltage gain for different configuration, common source, common gate and common drain. Okay, so let's start with CS common source configuration, common source amplifier. So this is, we are giving input Vi voltage at gate of common source and output voltage at drain, and source is grounded. So source is common to input and output. So that's why this is known as common source amplifier. Okay, so now we need to find out DC gain, ADC, that is GM into R out. Okay, so now let's find out GM for this circuit. So how we will find out GM for this circuit? We will ground output and we find ISC. So GM given by ISC upon VI. So we need to find out ISC upon VI. This is transconductance for this circuit. Now how we will find out ISC? So if we draw small signal model for this, so this is GM into VI, here RO, and this is ground. This is also ground, and this is ISC current. This is VI. Now if we see impedance toward this, we can say impedance for ideal current source is infinity. So here this is not connected. Now this is drain terminal or output terminal, and so we can neglect this resistor because both sides it's grounded. So small signal model reduces to this. So if we write KCL at output, this is output node, so we can write KCL at output ISC plus GM DI equals to 0, ISC upon VI equals to minus GM. So this is GM for CS configuration. We have already find out this, so I have just repeated here. Now we need to find out output resistance for this circuit. So for this we make input ground and we put one Vx voltage source, and Ix current is coming from here, so R out given by Vx upon Ix. So if we see here, impedance for this is infinity, and now VGS is 0. If we draw small signal, GM VGS and RO, this is Vx and Ix is here, this is RO. Now gate is 0, source is ground, this is drain, so this term is equals to 0. So small signal will reduce to RO Vx So Vx upon Ix equals to R out. Okay, so ADC gain is given by Gm into R out, which is given by minus Gm into RO. So ADC for common source configuration is this. Now suppose case we consider instead of current source, say consider this case that here some RD resistance is there, and this is Vi, this is Vo, this is VDD. Now we need to find out ADC. Now Gm for this is similar minus Gm. We can find out this. You can try. We can find, we make its ground, this is ISC, so this RD we don't have to consider this RD, so small signal again reduce and RO is here, both RO and RD between ground, so we neglect, so this is GM, VGS, and this is ground, this is ISC, this is ISC, and this is equals to GM V in, this is VI. I need to write this VI. So GM again given by this. Now we need to find out output resistance. So we will find out how we find out output resistance. So this is RD, we make it ground, this is RO, this is VX, this is IX, this is ground, this is RD. So this is small signal ground. So RD and RO are parallel to each other in small signal. This is RD, this is RO, this is VX, IX, this is ground, because GM VGS term will be 0 because here VGS equals to 0. Now, so R out equals to Vx upon Ix equals to RD parallel RO. So ADC given by GM into R out, which is equals to minus GM into RD parallel RO, ADC. If RD is smaller than RO, ADC given by GM RD. If suppose this current source having resistance, say we are RO, so it is something like that, we are mirroring current, this is PMOS here and this is NMOS, so this is say RO and this is some VB, so small signal ground, this is ground, this is VI, this is also RO, here also RO. So in this case R out equals to RO by 2 because RO and RO are parallel to each other. ADC given by minus GM RO by 2. GM remains same. Thank you.